Assalamualaikum warahmatullahi wabarakatuh. Hello, welcome to the Fundamental Physics Laboratory of ITS. Let me introduce myself. My name is Sylvia Nur Aziza, one of the laboratory assistants in the Fundamental Physics Laboratory of ITS. In this section, I will explain an experiment entitled Kirchhoff's law. Kirchhoff's law is a law in physics that explains electric current and also potential difference in a closed electric circuit. Kirchhoff's law consists of two parts, namely Kirchhoff's first law, also known as Kirchhoff's current law, and Kirchhoff's second law, also known as Kirchhoff's voltage law. Kirchhoff's first law states that the amount of current entering a branching point is equal to the amount of current leaving the point. In other words, the first Kirchhoff law focuses on the flow of electric currents and can be formulated as sigma I in equals sigma I out. Here, sigma I is the total electric current flowing in the closed circuit with the unit ampere. Meanwhile, Kirchhoff's second law states that the total potential difference in a closed loop of a circuit must be equal to zero. This can be formulated as sigma epsilon plus sigma I times R equals 0. Here, sigma epsilon is the total electromotive force of the current source measured in volt, and sigma I times R is the total voltage across the resistor component in the circuit, also measured in volts. The purpose of this experiment is to determine the electric current in each branch of the circuit and the amount of potential difference between 2 points in the circuit. Okay, the following are the tools and material for Kirchhoff's law. First, we have a digital multimeter, followed by one set of breadboard, one set of resistor, and then 2 batteries, and also 5 connectors. Okay, there are 2 variations used in Kirchhoff's law, namely the single loop circuit and the double loop circuit. Okay, for the single loop circuit, initially measure the voltage of the battery as well as each resistor. Okay, to measure the voltage using the multimeter is by turning the dial to the DC voltage reading. Then connecting the probes to the battery terminal. Okay. Next, to measure the resistance to each resistor by turning the multimeter dial to the resistance reading. The value of voltage and resistance should not be forgotten to be recorded. Then, take the battery and place it into the breadboard like this. Then take another battery and place it in the opposite direction. Do not forget to take 4 resistors and insert them into the breadboard in series. Place R1 and R2 like this. Then also place R3 and R4 like this. Do not forget to connect them using the connectors so that they form a closed circuit. As the closed single loop circuit is complete, it is time to measure the current and voltage using the digital multimeter. Okay, to measure the current, the circuit must be arranged in series. First, turn the dial on the multimeter to the current reading. connector and insert the probe into the hole on the breadboard. And yes, the value of the current will be displayed. Okay, remove the probe. To measure the voltage, we need to place the multimeter in parallel for each component. We will measure them one by one for each resistor 1, resistor 2, 3, and 4. Before that, reattach the connector so the current can flow through the circuit. Do not forget to turn the multimeter dial to the DC voltage. Then now insert the probe in parallel for each resistor like this for R4, for R3, R2, and R1. Do this for resistor and record the value. Okay, now let's move on to the double loop circuit. For the double loop circuit, we will use 2 battery and 3 resistor. First, take 2 batteries and insert them into the breadboard hole like this. Then take 3 resistor, which are R1, R2, and also R3. For R1, we place into the breadboard like this, and here we use 5 connectors and attach them into the breadboard like this. Okay, to measure the voltage and current, we use our digital multimeter. First, turn the dial to the DC voltage reading and insert the probe into the breadboard hole in parallel for each component like this. For R1, for R2, and this is for R3. Next, to measure current, since there are 2 loops, so we need to measure the current in loop 1 and the current in loop 2. Turn the multimeter dial to the current reading. Then unplug one connector from loop 1 and insert the probe. Okay, do not forget to retake the connector. Next, to measure the current in loop 2, unplug one of the connector. Then insert the probe into the connector hole that was just removed. Okay, record the current reading and remember to retake the connector. Okay, and lastly, measure the current of I3, which is located in the middle part of the circuit. Can plug the connector first and then measure the current. And don't forget to record the reading. And lastly, we also use the second resistor variation, in which R3 is replaced with R4, and the voltage and current value are measured again using the same method as in the R3 variation.
Alright, now we'll move on to the section on data and discussion from the Kirchhoff law experiment. This table presents the measurement reservoir of single loop circuit with variation in resistance number 4. The table consists of 3 columns. The first column is the component column, which includes the value of all components in the single loop circuit. This component includes resistor number 1, resistor number 2, resistor number 3, resistor number 4, the first electromotive force for the first battery, and the second electromotive force for the second battery. The second column shows the voltage measured by the multimeter across its resistor. Since we are using full resistor in the circuit, we measure for voltages, it representing voltage drop across one resistor. The third column contains the current value expressed in milliampere. This is the current measured by the multimeter. Because this is a single series circuit, the current flowing through each component is the same across a resistor. Now, this is a measurement table for a single loop circuit at variation of resistor number 5. The difference between this table and the previous one lies in the third row. In the previous table, the row was reversed for the resistor number 4. In this variation, it is updated to present resistor number 5. As before, you will need to perform voltage and current measurement using a multimeter for each resistor. Next, we have a measurement result for a double loop circuit with variation in resistor number 3. In this double loop configuration, we only use 3 resistors. We also measure the voltage across each resistor. Since we have 3 resistors, there are 3 voltage readings to take. The final column in this table displays the current readings from the multimeter. Unlike the single loop circuit, the double loop circuit contains 3 branches, which result in 3 different current values being measured. Now, we move on to measurement result for a double loop circuit with variation in resistor number 4. As before, the main difference lies in the third row. And the previous variation, it was resistor number 3, but here it is updated to resistor number 4. The voltage across each resistor is measured, along with the current flowing through each one. Okay, now we move on to the sample calculation. For this calculation, I will use a sample from the single loop circuit with variation in resistor number 4. We are given the value for resistor number 1, resistor number 2, resistor number 3, and resistor number 4. This value were originally in kilo ohms and have been converted to ohms. We are also provided with value for the first and second electromotive forces as well as the measured current, which is 1.5 milliampere. Additionally, the voltage measured across the first resistor, denoted as VAB, is 1.54 volt. In this Kirchhoff law experiment, we are required to determine the theoretical value of current and voltage for each resistor. This calculated value will later be compared with the measured value from the multimeter. For current, we begin with the equation. The sum of the electromotive forces plus the sum of current multiplied by resistance equals 0. Since we are using 2 batteries, we write E1 plus E2 plus I multiplied by the sum of R1, R2, R3, and R4 equals 0. Because this is a series circuit, the current is the same throughout. To find the value of the current, we rearrange the equation so that the current equals the sum of E1 and E2 divided by the sum of R1, R2, R3, and R4. By introducing the known value into the equation, we obtain a current value of approximately 1.76 milliampere. Now let's move on to voltage calculation. For this example, we focus on voltage across the first resistor, VAB. The formula is simple: the current multiplied by the resistance of the first resistor. So we multiply 0.0015 ampere by 980 ohm, and we get a result of 1.47 volt. We apply the same method for a remaining resistor VBC, VGE, and VEF. Next, we calculate the percentage error. Taking the VAB measurement as a sample, the error is the absolute value of the difference between the measured and the calculated voltage divided by the calculated value multiplied by 100%. By substituting that value, we get the absolute value of 1.54 minus 1.47 divided by 1.47 times 100%. The result is approximately 4.76%. After completing this simple calculation, of course, we present the full calculation result. This is the table of calculation result for a single loop circuit with variation in resistance number 4. The voltage section includes pole measurement and calculate value along with the percentage error. Please complete this table using your own experimental data. The same applies to current, including both of the measure and calculated value, as well as the percentage error. Here is the table for a single loop circuit with variation in resistor number 5. The structure is the same, only the value different. This table shows the calculation result for a double loop circuit with variation in resistor number 3. It includes measure and calculate voltage rate corresponding percentage error, as well as measure and calculate current value and their percentage error. We present a similar table for a double loop circuit with variation in resistor number 4. Now let's move on the discussion point. What should be included in this discussion section? First, please explain the data and analyze result you obtained. Second, compare your measured data with your calculated data. Are your value close? Is the error large or small? If the percent error is either high or low, please explain the possible reason behind that. Fourth, describe the differences between the single loop and double loop circuit. Explain how the voltage and current behave in each. Fifth, evaluate whether your experimental results were consistent with KIRCHHOFF'S first and second law. Also be sure to describe the physical phenomena that occurred during the experiment and relate them to the theoretical foundation you discussed in Chapter 2. Lastly, briefly mention and explain the possible sources of error in your experiment.
This is the explanation of the Kirchhoff law experiment. To see discussion on another experiment, you might visit the YouTube channel of the Fundamental Basic Laboratory of ITS. I'm Sylvia, signing out. Assalamualaikum warahmatullahi wabarakatuh.